All right, welcome back to another video in this series. This is going to be a two-parter, so two videos. So this is part one for network vulnerabilities, right? And we're going to do a few different things in part one. To get started, we're going to talk about network footprinting, right? So let's talk about footprinting, spoofing, and denial of service. So network scan is usually the first step in the attempt to penetrate security, right? Or to at least establish what needs defending. Now, footprinting establishes the topology and protocol displayed on the network, while fingerprinting determines the services and other configuration details of a target host, right? So one of the most popular scanning tools that a lot of IT professionals use is Nmap, right? So it's a command line program that operates using scripts, and a GUI version, which is Zenmap. Well, I call it Zenmap, but Zenmap is its total name. It can perform several very useful pre-configured scans, right? So, but what we're going to do here is just use the host containing vulnerable virtual machines that'll be used, which is on a different subnet to the devices in this lab. The purpose right now is just to demonstrate different vulnerabilities on these devices, right? So to start, we're going to use the Nmap. All right, and just make sure I'm in the right lab here. All right, perfect. So just go to vulnerability analysis. If I can find it here. Here. There is start. Okay, wasn't sure where the start was. All right, perfect, found it. All right, and then we're gonna go to Nmap here, because there was an issue with the lab, and they had to issue out a statement and things of that nature. But nonetheless, we'll keep the party going here. All right, so we have the root at Kali Nmap open. So we'll be scanning a vulnerable topology here, and we're going to find hosts in their open ports on the network where the lab devices are connected. So within the root here, I'm going to type in this command for the, let's see. I think it's this one here. That's right. TXT. The text file. Now the scan may take a couple of minutes. Then it may save our results in the file. Should be the file named after this. Oh. Let's see. And then once it finishes scanning, then I'll be showing another root prompt. There it is. Perfect. Yep. I'm confused for a second. Here it is. There's a root prompt here. I thought it was going to take a little longer, but that's cool. All right. So now that it's finished scanning, I'm just going to minimize this window here, and then I'm going to go back to the concept here. And let's see. There it is. All right. And there it is. All right, perfect. So now that we have LeafPad open, the file here. All right, then other places. Okay, root. Then host. There we go. Perfect, perfect. All right, so it'll show us here the results of the scan that we've just done, and the command I just placed into the other application. And we're just going to look for the host with the IP address 192.168.x or 0. Let's see. Right, perfect. So all of these, right? Really. Okay. All right, so let me just get out of here. All right, perfect. Yeah, those were fine. So I was just looking for between .0 and .24, really, pretty much for most, if not all of them. So now I'm just going to open this up here. All right, now that we got our terminal open, just going to identify the OS and send scan TCP ports using the SYN packet. So to do that, I'll type in this. See, I think that's what we put over there. There it is. It should take about 1 minute to complete. Right now, while that's doing that, I'll keep that open here. Then I'll open this back up. Then go here. Then open up another leaf pad. Right, and then see open. Then let's see. It should see. Okay, perfect. All right, now. Okay. All right, perfect. I was just looking for the IP address. It should be a pull between 0 and .24 again. Just here, 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 here. Yeah, pretty much all of them. Right, 6 host up to. All right, so let me minimize that. All right, perfect. Now I'm going to use Zenmap. So Zenmap is, as I mentioned before, it's the GUI, graphical user interface of Nmap, which is generally considered easier to use, I would assume, because of the layout of the outlook. Now, to use Zenmap, I'm just going to go here, open that baby up. All right. All right, now I'm just going to keep this open while I connect to the other server here. Should ask me for, yep. So again. Open up Wireshark. Oh, what's going on? All right. Yes. All right. Perfect. Now I just clicked this just to describe what I did. I just opened Wireshark just to capture the internet traffic from the Ethernet source, right? Which I initiated when I clicked the blue fin, the top left here. So I'm going to connect back to the server. But with the Zenmap still open, of course, so I'm just going to click in the target box here, and let's see. What's the first address? Let's see. Actually, you know what? I'll just use that one there. So I'll do. There it is. All right. Now, pretty much what I'm doing, I'm just doing the ones that were found. So .8. And so perfect. All right, perfect. All right, so I'm just letting it run the scan pretty much on the address, pretty much. And as you can see, it doesn't take long to do right now. Now that it's completed, it's just going to go back to here with Wireshark still open. And just going to click the capture menu and choose stop. Right. And then it's going to type in a TCP. If I can spell. Right. All right, perfect. Now just going to go to the source column here. And I'm just going to locate the IP address entered a few moments ago as far as the vulnerable host. Now, when the Zenmap port scan was run against the host, network applications, they usually reply with a SYNAC, like a sequence and an acknowledgement packet when a connection is made to it. Then the Zenmap tool will send the reset to tear down the connection usually, right? So now I'm just going to go back to the other server here with the Zenmap still open. I'm going to click in the target type here. All right, and I'm going to type in, let's see, 27024 and scan here. All right, so this is going to scan available hosts pretty much mentioned, and then the target that I put here. It may take, even though the last one they took, they were fairly quick. This is going to take usually about 3 minutes for it to complete, at least in that time frame, 3 to 5 minutes. Now, when the scan completes, usually the host, it should indicate the IP address of the computers detected in the scan. Let's see. Server scan. Should see the one I just placed in there. Always host start down. Okay. Let's stick here. All right, I'm just waiting for it to finish. It should be finished in just a moment. All right, so it's finally completed, and now, as you can see here, this wasn't here before. So now that it's completed, it has a couple different hosts here to our left column, different hosts for further details into the host, right? So we click on this, or I clicked on this one, the .18, and they give us different information as far as the TCP, the status, the FTP, the version, the state, and things of that nature, right? So I'm just going to click on the topology for this one. All right, then fisheye. And it's just going to show us the discovered network hosts that were detected by the scan, right? So now I'm just going to take a look at host details, right? Accuracy 97%. It's pretty good for 100, but let's see a few things here. Okay, this looks pretty good. All right, so now I'm just going to see the summary detected open ports in the IP address. Let's see, looks pretty good. Yep, so we successfully taken care of that. I'm going to close anyway. Perfect. All right, so next what we're going to do is some packet sniffing, good old packet sniffing. Of course, naturally, we're going to use Wireshark, but this is another critical information gathering tool as far as a protocol analyzer, right? So this tool usually captures unicast packets, right, sent to the host and broadcast the packets on the same subnet. So the most widely used is Wireshark, as I mentioned. That's what we're going to use today, which is usually bundled with Kali Linux. And first, what we're going to start with is observing traffic pattern using the application Wireshark. So let's make sure we're on the right server using the Wireshark. All right, and then let's see, do open here, mobile network captures. All right, perfect. So this is a network capture from the vulnerable topology, right? So I'm just going to clear the filter There's one here. Let me clear this out. There it is. All right, perfect. All right. All right, perfect. So now let's take a look at the statistics for here and the conversations. Join them. All right, so now we're presented with Ethernet addresses for the devices on the network. And I'm just going to click on this one here, get a better look. Now this section just shows us the devices which are communicating on the network, and we can see that the device with the IP address that we saw previously is having quite a few conversations with various addresses on the network, right? Let me actually open this up just a bit, see a little bit better. Oh, come on. Let's open this back up. Perfect, perfect. All right, so just gonna click on this tab also. Now here we can see the same device has traffic flowing in sequence from ports 60251 and also from 60251 to 60296. All right, let's see here. This side, there it is. You see 60296. Right, and then you can see 60251 is somewhere up in here. Somewhere in here. Right, there it is. All right, perfect. So, perfect. So now that we've covered a bit of package sniffing, this is the end of the video for part 1 of network vulnerabilities. Again, what we've done in this video is we took a look at network footprinting, and also packet sniffing. I'll see you in part 2.